Dear friends, today we will discuss about electric flux and gauss law. So let's first start. What is electric flux? Electric flux. First, try to understand the word flux. What is it? This word comes from flow. Flow, flux. When something flow, something pass through a surface, then this quantity is required. Something flow. What flow? You take a pipe. Here, what flows through this pipe? Air flows through this pipe, or water flows through this pipe. When something flow, water flow, so how much amount of water flow? Then this flux word is required. When something flow, something pass through a surface area, then the flux is required. You have heard, I think in 11th class, in fluid chapter, E flux. In Torricelli's theorem, something passed through one orifice, E flux. Okay, so we'll discuss the flux here. But here, what is this electric flux? Means something related to electric field. What is the requirement of this quantity first? Why will we read this quantity? I told you something pass, something flow through a surface area. The same thing here. Here what pass in this chapter? Electric field lines. Here electric field lines pass through a surface. That can be determined by this quantity called as electric flux. Then what is the need of this quantity? What we read here? What is flux, electric flux? Why will we discuss this quantity? To know how many lines of forces passes through a surface, or it determines how many lines of forces are linked with a surface. This can be calculated by electric flux, or this quantity. So what is the advantage of it? Now we'll go. How can you calculate this electric flux mathematically or quantitatively? Qualitatively, we got the definition. It determines how many lines of forces are linked with the surface. But quantitatively, how will we measure? We cannot count the lines of forces 1, 2, 3, 4 like this. They are the imaginary lines. So how we will calculate quantitatively electric flux means I am just telling what is the formula of the electric flux. So now let us see. I am taking one surface like this. This is a surface. You see, this is another identical surface. Both surfaces are of same area, suppose. You see, here some lines are linked, and here some lines are linked. Now you see, in which case more lines are linked here? In first case or in the second case? This is first case, suppose. This is second case. In which case more lines are linked? Okay, so your answer is in second case. More lines are linked here. In second case, more lines. If more lines are linked means lines of forces are crowded. Lines of forces are crowded here. With the same area, more lines are linked. But with same area, less lines are linked. Means lines of forces are crowded here. Lines of forces are crowded means you go to the property of lines of force. Where lines of forces are crowded, their electric field intensity is more. If we go in the reverse way, more is the intensity, more is the crowding of lines of force, more is the flux. Then flux depends on which quantity? Flux depends on electric field intensity. If it is more, also it is more. Means directly proportional. Then, now I am giving you another situation. See here, this is a surface. If suppose this same surface, you see, this is the crowding of lines of force. I am not disturbing the crowding of lines of force. That means I am fixing electric field intensity. Electric field intensity I fix here. Suppose I will make this surface like this. Now you see, I same one, but I am now see making the surface like this. You see now what happened here? What happened here? See, when the surface was small, the lines linked to the surface are less. When the surface becomes more, then lines linked with the surface now becomes more. Means how many lines will be linked with the surface? That depends on area of the surface. More is the area of the surface, more will be the number of lines linked with the surface. So also it depends on area of the surface, means surface area, also directly proportional. Now let's come to another point. I am just giving one example. I am taking a surface like this. You see, lines are coming here. You see, so electric field lines are coming like this. Lines are coming suppose like this. These are the lines. These are one lines. They are coming like this. Some lines are linked with the surface. This is case 1. Okay. Now coming to this one. Just I change the orientation of the surface. Same lines are coming. You see, is the line linked with the surface? No. Same line, is the line linked with the surface? No. So now line linked to the surface. But you see, case 1, you see lines linked to the surface. Case 2, you see lines linked to the surface. In which case, in which orientation, in which case more lines are linked? First case or second case? Okay, so your answer is first case. Here it is practically now you see first case more lines are linked, but in second case number of lines of linked are less. That means the same electric field is same, area is the same, but again number of lines linked also depend on some other quantity. What is that other quantity? You see, in this case you see now this is the electric field direction, and see this is the surface. You know, surface area is a vector quantity. So now we will take this vector, and always surface areal vector is perpendicular to surface. Areal vector is perpendicular to the surface. You see, this is the areal vector. Is it clear? This is areal vector, and this is what? Electric field. What is the angle between them? 180 degree. If we take this side surface, the lines which linked with this also will link with this. Okay, you take this side surface. Electric field is like this. This is the electric field direction. This is the surface area direction. What is the angle between them? 0 degree. So if I take this surface, 0 degree. If I take this surface, 180 degree. That means when the angle is 0 or 180, then this quantity, amount of flux, amount of lines suppose linked, means this flux is maximum. Is it clear? Practically I show you it is maximum, but in this case it is minimum. We have discussed. When it is minimum, you see this is which vector? Areal vector, or you can take this surface. This is areal vector, this is areal vector. This is electric field. Electric field vector, areal vector. What is the angle between them? Areal vector, electric field. What is the angle between them? 90 degree. That means when angle is 90 degree, then this flux is minimum. Now you come. So electric flux linked with a surface depends on the orientation of the surface. Orientation of the surface. The angle between electric field and surface areal vector. Areal vector, not with the surface. Surface areal vector will take angle between electric field and areal vector. Surface and surface areal vector are perpendicular to each other. This is surface, but this is areal vector. They are perpendicular to each other. But I am taking the angle between electric field intensity and areal vector. Okay. When the angle is 0 or 180, flux maximum, angle 90, flux minimum. You tell me which trigonometric quantity is maximum at 0 or 180 and minimum at 90? Is it sine? No. Is it cos? Yes. cos 0 maximum, cos 90 it's a minimum. Okay, so that means here flux depends on cosine of angle cos theta, cosine of angle between electric field intensity and areal vector. Now you got the formula flux. So flux is equal to Es cos theta. Why the formula is Es cos theta? Now you got the idea. Why the flux formula is Es cos theta. So this is the formula of flux. If cos theta and these are two vectors, now you are thinking it must comes under a product. Which product? E vector dot S vector. Scalar product or dot product of electric field intensity and areal vector. Is it clear? So this is about flux. Flux formula. Then come, if this surface is not a plane surface, suppose surface is a curved surface, or angle vary, angle is also not constant. In those cases what we'll do? We'll use integration formula. We'll find by integration E dot ds integration. Remember, I am giving you two formulas in which case the surface is curved, angle varies. We have to use this dot product method. We have to use this integration method. But when the surface is plane surface, electric field is constant direction, then we use simple formula E vector dot S vector for plane surface, uniform electric field, constant electric field. So this is about the formula for flux. So we can say, if the question will come, define electric flux, what we can write? Electric flux linked with a surface is defined as the dot product of electric field intensity and areal vector of the surface. Simply we can write like this, or we can write like this: the small integral of the surface integral. This is called surface integral. Okay, so this surface integration is of three types: line integration, surface integration and volume integration. But now I am discussing about surface integration is done over the surface, is called surface integration. Or we can say flux linked with the surface is surface integral of dot product of electric field and elementary areal vector. Elemental area, because I am taking a small area, this is called elemental area, elemental areal vector. Okay, so this is about the definition of flux, electric flux. Similar flux also will discuss after one chapter in magnetism, that is magnetic flux. There which lines will be linked? Magnetic lines will be linked with a surface. Same thing, only electric field will be replaced by magnetic field, but everything is same. If you understand this one clearly, there it will be easy for you. Okay, but we will not go to that now. Let's concentrate on electric flux. Then what is the SI unit of flux? What is the SI unit of flux? SI unit, you see ES cos theta is no unit. So Newton or Coulomb, and S is meter square. This is the SI unit. Newton per Coulomb into meter square. What is the CGS unit? Accordingly, dyne per start Coulomb into centimeter square. And another CGS unit, dyne per half Coulomb into centimeter square. So these are the two units, ESU and EMU. Then what is the dimensional formula? You can find the dimensional formula from the unit. You see, dimensional formula. You can write the dimensional formula: force M1 L1 T minus 2, and this is charge Coulomb. So A1 T1, and this is meter square, so L square. Then you can solve it. This is up to you. You will solve it. Okay. Then let's come. It is scalar vector quantity. It's very clear. This is scalar product of two quantities E and S. The flux is a scalar quantity. It's not a vector. It's a scalar quantity. When you will add flux, you just do simple addition as you have done in your lower classes. Simple addition, plus minus, simple addition you will do. So this is about the electric flux. Now let's come to discuss some cases about this flux. What cases we discuss? You see, I am taking one uniform electric field. This is one uniform electric field. I am taking a surface like this. From this, let's choose one elementary area here. Very small area I am taking. Let's choose one elementary area here and one elementary area. Very small area I am choosing. So its areal vector will be in this direction. It's right. ds1 vector, small area. So I have here ds. Here this is ds2 vector. Here this is ds3 vector. So now see. First come to case 1. Discuss about the first one. This is the electric field vector. What is the angle between electric field and ds vector? This is the angle theta. Is it greater than 90 or less than 90? It is less than 90. If it is less than 90, first case 1, for surface S1 I am discussing, theta less than 90. What about cos theta? It is positive. If theta less than 90, then cos theta is positive. If cos theta is positive, what about flux? Then flux is positive. Flux is positive. It is scalar quantity. But what is the meaning of this positive sign? If flux appears in positive sign, it has some significance. It is very important. What is the significance of it? See, the lines of process are passing from this side, from this to this side. Okay, so through this surface lines of process are entering and through this surface lines of process leaving. So at this elemental area, lines of process are leaving. So that means what the positive flux indicates? Positive flux indicates lines of forces are leaving the surface. Remember, positive sign of flux means lines of forces are leaving the surface. Then come to case 2. Case 2. Now come to S2 surface. This surface. Theta is here 90 degree. The flux length is equal to 0. Cos 90 is 0. The flux length will be 0. If the real vector and electric field are perpendicular to each other, then no flux is linked with the surface. You see this situation. This is the aerial vector. This is the electric field. At that time, no flux will be linked with the surface. Now you see case 3. What happened in case 3? S3 surface. What about the theta here? This is the theta. Is it clear? This is the theta here. And theta is greater than how much degree? 90 degree. Means here theta greater than 90 degree. So what about cos theta? Cos theta is negative. If negative, what about flux? Flux is negative. What the negative sign of flux indicate? Flux negative means lines of process are, you see, entering. Lines of process are entering through the surface. Now you got the idea. What is the meaning of positive sign and negative sign of the flux? The positive sign of the flux means lines of process are leaving the surface. Negative sign of the flux means lines of process are entering the surface. It's a very important concept. One question came in 2020 board examination based on this concept. Well, I'll discuss that question later, but based on this concept the question came. You will change the plus minus sign, you will get 0 obviously. Okay. So this is about the positive and negative sign of the flux. So like this we can find the flux with any surface. We will find some questions in your book, in your NCERT book. One very important question, your example 1.11 and 1.12. Those two questions you can solve. They are based on about electric flux. You can solve those two questions. They are very important questions, and I am also telling you that 1.11 example came in 2020 board examination this year. Example 1.11 with a little change. With a little change, that question came as a 3 marks question. It's a very important question. 1.11 example also always comes in the school exams. Okay. that you can try. I'll discuss that later in my next video. Then we'll come to another thing I am telling you. One question now I am keeping in front of you. Suppose Q is here. Q is a positive point charge. Q is here. I am taking a surface like this. See, I am taking a surface like this. This is positive plus Q. Lines of forces are leaving the surface. Lines of forces are now leaving the charge. They go away from the charge. Lines of forces pass like this. Many lines pass like this. Okay. So here what happened? One thing I am telling you, some students have the misconception. If this is a plus Q charge, it's a point charge. From point we know in lower classes how many lines can originate from a point? Infinite number of lines. Then we can draw infinite number of lines here. No, geometrically you cannot draw the lines like that. How many lines will be linked? That depends on the magnitude of the charge. If you draw geometrically infinite lines, then there will be no meaning of plus 2 coulomb and plus 2000 coulomb. That means you are thinking, if this is a point charge, here also infinite lines will come, and if this is a point charge, here also infinite lines will come. Then the electrical intensity will be same for both. No. So these are imaginary lines. You cannot count the lines like that. For which we are discussing this flux. For that only we are discussing the flux, how many lines are linked with a surface. As we can't able to count, we are calculating mathematically this one. Now you see, I am giving one challenge to you. Plus Q is here. This is a surface, irregular surface. It is not spherical surface. My question is, can you calculate flux linked with this surface? It is a closed surface. Closed surface but irregular curve. Can you calculate the flux linked with this curved surface? If you want, you can pause the video and you can try this one. Okay. So I know you can't able to calculate this one because it's irregular, completely irregular, no specific angle between this is the direction of electric field intensity, but aerial vectors are in different directions. No specific angle with aerial vector. It's very difficult to find, you cannot find. But you cannot find, how can you do this one? We can find by some trick ways. By some tricky way you will do, then you can able to find. For the trick way I use your brain. Let's do one thing. Let's draw one regular surface. Let's draw one regular surface here. Spherical surface I now choose. I choose one spherical surface. Okay. This spherical surface I am taking up radius r. I choose one spherical surface, enclosing the charge at the center and also covering this surface I draw. I will calculate the flux linked with this regular sphere, spherical surface. Then I will get the answer with the curved surface also. How? If one line start from plus Q, that link with the curve, that also link with the what? Spherical surface. How many lines will start from this plus Q? Those who link with this irregular curve, they also link with this irregular sphere. So why we are bothered about to calculate about this irregular curve? Better you calculate with this regular curve surface, regular sphere. It's very easy to calculate with a regular sphere. Okay, so in trick way now we'll find out this regular sphere. You will find out this regular sphere. Then how much flux we get? You will get the flux Q by epsilon naught. If it is vacuum, you will get the flux Q by epsilon naught. I am not telling you this answer. From where I get this answer? So I am not telling you this one. Gauss told you. Gauss, renowned scientist of electromagnetism, who gave a lot of law, who studied a lot, did a lot of research about electricity and magnetism. Gauss gave the law. This is the Gauss law. Now our discussion will be about Gauss law. Very important law. Gauss law. Sometimes also it is called as fundamental law of electrostatics. It's a very important law. Now let's discuss. So what is this Gauss law? Gauss law states that, in exam the question will come, state Gauss law. Alright? it states that the electric flux linked with a closed surface. The electric flux linked with a closed surface is equal to 1 by epsilon naught times charge enclosed inside it in vacuum. Electric flux linked with a closed surface in vacuum is equal to 1 by epsilon naught times charge enclosed within it by inside it. Is it clear? Okay. Two words you will must underline. One word is closed surface. This law is only valid for closed surface. Second word is in vacuum. If you forget these two words, then you will get 0 mark in board examination if you write. Okay. So now let us see. But we will not believe Gauss like this. We will prove it. Then we will believe on it. Proof of Gauss law. How we prove this Gauss law? Now let us see. Take a charge, positive point charge I am taking. Choose a surface. I choose one surface on which I will calculate the flux, and this surface is called Gaussian surface. The surface on which Gauss law is applied is called as Gaussian surface. It is suitable chosen. According to your comfort zone, you will choose the Gaussian surface according to your requirement. Okay, so I choose the Gaussian surface, one spherical surface. You may tell, sir, why you are not choosing one irregular curve? You can choose irregular curve. Can I able to calculate? No. For according to my comfort zone, I choose the Gaussian surface, one spherical surface. Now you see, its electric field lines will pass like this. This is also the direction of electric field intensity. Let's calculate the flux. Which formula we will use here? E dot S or E dot ds integration. Okay, as it is curve, obviously integration will be used. E vector dot ds vector integration. Okay, this is the flux formula. I have already told you surface integration. You can write S. If you not write S also no problem. So this is the intensity vector. This is the intensity vector. I choose a small elementary area here. Let's show. This is ds vector, small elemental area, and its areal vector will be like this also. Areal vector will be also like this along the radius. Electric field is also along the radius. What is the angle between them? Anywhere you can choose the intensity or areal vector. What is the angle between them? 0 degree. So this is E ds cos 0. Is it clear? Then what about E? E is kq by this radius is r. So r square. On this surface area, what is the electric field? Kq by r square. I have to find on the surface electric field. So this is ds. K constant, q constant, r constant. Take it to outside. But the integration of ds only remain whole surface area. Whole surface area integration only. The whole surface area K is 1 by 4 pi epsilon naught. If it is vacuum, what is ds integration? 4 pi r square. Now you see 4 pi cancel, r square cancel. What will remain? Q by epsilon naught. This proves Gauss law. It can come as a 2 marks derivation in board examination. State and prove Gauss law. Statement half mark, prove 1 mark, and figure half mark. This is the mark distribution. You may get a question like this. So this is the proof of Gauss law. Is it clear now? Okay. So some questions may come from this Gauss law. Now let us discuss what questions can come from the Gauss law. What is the final formula of the Gauss law? Phi equal to Q. I am writing in epsilon. Why in? In stands for inside. Always remember, in stands for inside. How much inside present will take. And also in place of this phi you can write E vector dot ds vector integration Q in by epsilon naught. This is the flux formula. But only when you write this formula for Gauss law, you can write a close sign here and surface integration. Close sign. What the close sign indicate? This close sign indicate you have done the integration, you are going to do the integration over a closed surface. But in normal flux formula, you write E dot S. But when you write this flux formula for Gauss law only, then you keep this closed sign. Is it clear? What is the difference between these two? For Gauss law, when you write, it will be closed sign. For general, you do like this. Okay. Some important concepts we will discuss based on this. On which concepts questions you may face. First concept I am telling about Gauss law. If instead of vacuum, this will be some dielectric medium will be inside, filled with dielectric medium, then what about the flux link? Flux link phi will be Q in by epsilon naught K. K is dielectric constant. From where this K come? Because electric field formula will change. Electric field formula in the derivation will be 1 by 4 pi epsilon naught K Q1 Q2 r square. If dielectric medium is there, then 1K will be added here. Because in electric field formula K appear. First point, this may come as a question in the exams. Okay. Second, I have taken the surface like this. If I make the surface double, if I make the radius of the surface double, do you think the flux link will change? Do you think the flux link will change? Flux link will not change, because what line is linked with this surface, the same line also will be linked with this surface. As long as the charge present at the center is fixed, as long as charge present at the center is fixed, so flux will not change. If you ask me, sir, mathematically how it is possible? Because now surface area increase. When surface area increase, simultaneously electric field decrease. Electric field decrease, surface area increase. Again the flux will be constant. Mathematically also it is proved. Physically also you see the same line also will be linked. So that means I am telling you one point concept here. Gauss law, when used, Gauss law is independent of the area of the surface if charge enclosed is same. Gauss law is independent of the area of the surface if charge enclosed is same. Okay, that may mean any surface, may be a square, maybe not square actually, maybe a cube, or maybe something. No problem, you can do like this. So this is one important point about Gauss law. And third one I am telling you, the charges present on the surface and outside the surface are not taken into account. Only the charges present inside the surface are considered. The charges those who present on and outside are not taken into account. One question came in 2020 board exam. One surface is like this, you see, curved surface. Q1 charge is here plus Q1, here minus Q2 charge is here, Q3 charge is here plus Q3, Q4 charge is here minus Q4. Like this one question came in 2020 board exam. What is the flux linked with the surface? Do you consider these two charges? No, because they are present outside. You see, flux phi is equal to Q1 minus Q2. Net charge Q1 minus Q2 divided by epsilon naught. Q1 minus Q2 divided by epsilon naught. This is the answer. If it is vacuum, epsilon naught. Q in, Q1 minus Q2. Is it clear? This is about the Gauss law. So based on this Gauss law, you can solve your answer book. Example I told you 1.11, 1.12. Also from exercise you can solve from question number 15 to question number 20. But from 15 to 20 when you will solve, question 18, 19, 20 are very important. Question number 18 and 20, they combinedly come in 2018 board examination. 2018 board examination in 5 marks question, question number 18 and question number 20 combinedly they come as a 5 marks question. 18 to 20, that is very important. You can solve the questions from NCERT book. Again I am telling from 15 to 20 will solve. Then I will discuss about these questions and applications of Gauss law in my next video. then you follow it. Thank you.